Okay. Well, good afternoon, everyone. Pete Follett here again. I think I've had most people on since we've started, so got a bit of a context of this Queensland Water Modelling Network activity, and yeah, we're keen to share and showcase some of the great work that's been done. There's been a lot of projects. But from the outset, can I acknowledge the traditional owners from where I am here in Brisbane here today, Minjin, the Turrbal and Jagera people, recognise elders past, present and emerging, and acknowledge any Torres Strait Aboriginal people that might be online today. Thank you for joining us all. Look, our speaker today is She Lim, who's actually speaking to us from downtown Singapore today, but normally based in Cairns, but she's been happy to come and share. And some of her project team are online as well. But I know at the moment we've got Marcus Bulstrode and Felix Eager, Marcus from DAF and Felix from Alluvium. So we'll see if anyone else joins later. But look, I think we're exploring this concept of paleochannels and what they might mean in the context of how floodplains operate in North Queensland, what it might mean for nutrients, what it might mean for managing of the paddocks, and I suppose in even extreme extents, what it might mean for any watercourses that are re-engaged after big flooding events and shifting. So She, with much pleasure, I hand over to you. She's from James Cook University based in Cairns, and she's got a great story that she's happy to share. So over to you, She. And look, folks, if you've got questions as you go along, feel free to throw them in the chat, and you know, we'll mix interactively as we go along as well.
Thank you, Pete. Thank you. And thanks, everyone, for your time, for coming to listen to this project. I'll make it simple because some of you have heard it before, and it's really just a preliminary project that we worked on for just 1 year. And at the end, I think what I'd like to do is really to focus on what are the opportunities for future work, and your comments or suggestions will be most welcome and useful for us. So this project is a collaboration between many teams from both government agencies, Alluvium consultancy company, and NRM groups such as Jerrigan. So
yeah, you go ahead and share.
Yeah, I'm oh, I haven't shared yet. Sorry, I'm still. Let me share my screen.
Right.
Okay, so. Here we go. So this is a typical landscape that we see up in far north Queensland. It's a narrow coastal strip, so the floodplains are quite intensively used for agriculture. And for those of us who are from Australia, and also maybe beyond, you've heard that runoff from catchments often can cause a problem for coastal areas, particularly the Great Barrier Reef. And the Queensland government has invested quite a lot of money in trying to model the catchments to look at their nutrient loads and contaminant loads, so that would be nutrients and pesticides entering the coastal areas. And coming out of this modeling, because this is a modeling group, so one of the questions that we had was, you know, how do we model at smaller scales? Because the catchment models that this GBR modelers are working at are large catchments. But when we want to know about water movement and contaminant transport at the intermediate scale, or even at the smaller scale of individual paddocks or agricultural fields, we really don't have, well, we do have the models to model at that scale, but the link between the smaller scale models and the larger scale models are often not very clear. So what we want to know then in such landscapes is that we know that most of the water flows through in the rivers and in the agricultural drains that are dug up by the farmers. But also, if we look at this picture carefully, we know that there are, well, signs of old river channels which may transport water underground or below the surface. Have we actually captured?
Good. Oh, you're going in there.
Have we actually captured the the water movement and contaminant transport in these additional flow pathways? in our models, and can we actually do it? And if we're missing out these water pathways that are moving water and contaminants to our surface drainage network, are we missing out contaminant loads, in our estimations of the loads that are transported from land to sea? So if we better understand the behavior of these unseen flow pathways, then it might help also in our management decisions when we build infrastructure, for example, wetlands, the positioning of wetlands or bioreactors, to capture some of these contaminants and treat them before they go further downstream. So that was the kind of conversation we had at the corridor, which came about this project, which was trying to understand these unseen flow pathways, mainly in the form of paleochannels, which we find quite widespread in the coastal floodplains of far north Queensland and also beyond other parts of Australia and elsewhere. So in order for us to start trying to understand and model the systems better, we need to actually understand how water flows in the agricultural landscape. And so this is just a conceptual diagram, which most of you would have seen in any hydrology textbook. So water can come down in agricultural landscapes and as rainfall or as irrigation water, and it can flow on the surface or in subsurface pathways, either in the unsaturated or saturated zone. And in such a flat coastal area where topography is really flat, subsurface water can flow both ways into the river or vice versa, back from the river into the subsurface areas below the ground, especially during flood periods when the water level rises in the river. Now, in a system where we have paleochannels, so these are individual paddocks or agricultural fields, if you have a paleochannel in the field, what happens is that these paleochannels can intercept some of the subsurface water that's flowing and behave as an additional flow pathway, which can connect with your surface drains or with your rivers. All right, so it's underground, we can't see, but it could be very active. And from the field experience of both Dave Morrison, one of our team collaborators, and Marcus, they can actually vouch to say that the locations, the paleochannels which they have dug up in the course of their fieldwork is actually can be quite wet. And we can have Marcus to share a little bit later on. So that's a paleochannel. And they behave as additional pathways of water movement and contaminant transport. So we thought, okay, this is a one-year project, can't be too complicated. So these are the methods that we're going to use. We're going to use field mapping techniques. And then with the field mapping techniques, we're going to do some spatial mapping in the NICE school office. And then the information gained through field mapping and spatial mapping going to go into a model, numerical model, which we set up a modeling framework. So the field data and spatial mapping information goes to support the numerical modeling work. So for the field mapping, we were actually quite sneaky because we didn't actually do the field mapping. We used the results from a previous project. So that helped us save time. In a previous project led by Dave Morrison from DEF and Jarragon Ecoservices, they did field mapping using electromagnetic induction techniques. So that's the instrument there, which you tow with a tractor, I guess. And also with the help of Marcus, sorry, Marcus, I spelled your name incorrectly. Drone mapping, they were focusing on looking at understanding the soil properties to help understand the factors that affected crop yield. But we thought that the EMI data that resulted from this project could be useful in helping us to identify where the paleochannels are in the study area. So this map on the left is a map that was processed after the EMI mapping. And you can see that the darker areas show the locations of these paleochannels, which they're not visible. Well, they are kind of visible from the surface, but with EMI mapping techniques, it becomes clearer. And so once we process this information further, we came up with this map here on the right, which shows the locations of the paleochannels. Now, all of you who are looking at this will ask me, Hanshi, why is the middle area not mapped? These paleochannels shown in pink lines surely must connect. Well, the reason, which I'm very embarrassed to say, is that the project which Dave Morrison was working on was focused only on sugarcane cropping areas, which were these areas, and the areas in the middle were not sugarcane cropping areas, so hence they were not mapped. And that could be an area of future work, complete the mapping exercise. So then we have the field data, which shows us where the paleochannels are. We have some information about the soil properties of the paleochannel infill material. So the next step is, how can we use this information to help us better understand how paleochannels move water? And so we decided to use models. So for example, if you look at this plan view here, when water, if you have surface runoff on a paddock here, it could flow from the paddock into the drain, if you can see my mouse, or it can flow into the paleochannel and then move underground, depending on how wet the paleochannel is. So the movement of water in this paddock really depends on the location of where that surface runoff is with respect to its position relative to the paleochannel and the drain or the river. So what we thought was, okay, we're going to set up a modeling framework and do virtual experiments, changing the configuration of the paleochannel in order to try to understand how water moves in the landscape. Now, the choice of using virtual experiments or virtual modeling experiments was because it is not really possible for us to monitor every paleochannel. It would be too expensive and, yes, it would be too difficult. And we don't have the time in our one-year project framework to do the monitoring. So hence we decided to do virtual experiments with models. So because this is an agricultural area, we had to model the water balance of the crops, and we decided to use APSIM, which it's a commonly used model in Australia. And because the groundwater subsurface water flow dynamics is so complicated, you have two-way flows, you have subsurface water interactions, you have a water table that is very dynamic, moving up and down. So we had to use a higher level groundwater model. And so we chose ModFlow. And once the water is subsurface and surface water is channeled into a drainage network, we have to route that water downstream. And so we decided to choose a surface water model such as HEC, HMS, or SWAT. So it's actually quite a complicated modeling framework where we had our input information of climate data and soil data go into our APSIM crop model, which then models the water balance of your agricultural crops. And the drainage, which was modeled, which is in 1D, is treated as recharge going into our 3D ModFlow or groundwater model, which can model water in 3 dimensions and at a grid scale, which is good because you can model water moving from subsurface water moving from one grid, moving down to the next grid, which could be a grid which represents an agricultural field into another grid, which is a paleochannel. So this is how we conceptualize a virtual paddock. So we decided to make things simple, start at modeling a paddock scale first, a small scale, and then scale up later on. So this is a virtual paddock, as you can see, and we are modeling in the X, Y, and Z coordinates. Yes, and so our virtual experiments took 2 forms, okay, 2 forms, very simple. One is to model a paddock with no paleochannel and versus a paddock with a paleochannel. Okay, so this would be modeling a paddock with no paleochannel. And these are the results which you see on the left. We won't go too much into the detail of the results now because this is just kind of like an intro. So you can see this will be the plan view of how water is moving, and the colors represent different grades of specific discharge in units of length per unit time. And this picture here on the bottom shows the subsurface flow of water modeled by ModFlow. The other experiments that we did were to look at the presence of paleochannel and whether the paleochannel was at the surface or paleochannel was located at depth. So that means below the ground, which we can't see. And we also got the results. And again, this is the mold flow results. And we found that when we have a surface, a paleochannel, which was located close to the surface, that actually increased the outflow of water from the paddock, which increased, well, it's not a lot, doesn't look like it's a lot, 3.5%. So this is just an example of some of the experiments that we did. So basically just 2 experiments due to the limited nature of the project. Now, in order for us to actually parameterize the virtual paddock, we needed to have a kind of idea of how the paddocks were configured in the landscape. And so this is where the spatial mapping exercise came in. So first we needed to know which paddocks had paleochannels, which paddocks didn't have paleochannels, what was the proportion of paleochannel area within a paddock, and how was the paleochannel shaped within the paddock? Was it running parallel to the agricultural drains or diagonally across? And so to get a better understanding of this, this is where the spatial mapping came about. So here you can see that a map of the paleochannels. You can find that most of the paleochannels, paddocks with paleochannels, a lot of them are found here in this part of the study area, which is actually just adjacent to the Russell River, which flows in this direction downstream. And we have some paddocks with no paleochannels at all, shown in gray. Yeah. So then the important thing is when we scale up, we need to be able to see how we can model the connections between paddocks that have paleochannels and paddocks that have no paleochannels. The other thing that was really important was to look at how these paleochannels intersected with other drainage elements in the study area. That would be your agricultural drains and your rivers. So these lines that are colored that you can see here, it's a bit hard to see, will show you the proportion of a paddock boundary where there is an intersection between the paleochannel and a drainage line. Drainage line mainly would be agricultural drains. We also looked at the distance in the paddock, any point in the paddock, the distance from that point to a paleochannel. Is a point in a paddock closer to the paleochannel or to an agricultural drain? And so this map provides that kind of relationship for paddocks which have paleochannels inside them. So if you look at this area here, where my mouse is, you can see that the paleochannel is running diagonally across this area, and it would cut horizontally across some of the individual paddocks. And these types of information actually help us parameterize, or decide the configuration of our paleochannels when we do our virtual experiments. So what I've described to you is actually just what we did in 1 year. We didn't do a lot of virtual experiments, but what we would like to do in the future is to do more virtual experiments. So for example, changing the aerial coverage of paleochannels within a paddock. So if we have, this could be a paddock, which is predominantly agricultural land with a small proportion of paleochannel. What if we increase the area of paleochannel to this size? How would that affect the outflow of water coming out from this paddock? And if we keep changing the aerial coverage of the paleochannel, we might be able to come to an understanding where we might know, oh, okay, there is a threshold beyond which the aerial coverage of paleochannel plays a significant role in transporting water out of this paddock. And so once we know these threshold values, then it becomes really useful to decide, for example, which paddocks you want to apply your management infrastructures or not. The other experiments, the other experiments that we could try was to try, having paleochannels at different depths, having a paleochannel at depth or having both a paleochannel at depth and at surface. How would that change the amount of water flowing out of this paddock? Now, to help us with these sorts of virtual experiments, some of our team members are going to conduct some field monitoring experiments, and hopefully, if they're willing to share the information, the data from these monitoring experiments, then that would be really useful to use to calibrate and validate our virtual modeling attempts. So that's basically the end of my sharing session. Just end with this picture from Marcus. You can see surface pathways of water movement, but we're pretty sure that water is moving underground as well.
Okay.
Yeah.
This is the report from Dave, the actual methodology to pick up the, yeah.
Yeah. You can also get the data from Dave's experiment here on QSpatial as well.
Yeah. Hanshi, I'm just conscious that if Felix is ducking off soon.
Yes, sorry. Yeah.
I've just had a quick chat with Felix, and Felix, if you wanted to come online and just say hello to everyone. I was just curious in working with this report, in working in this project with the team, were there some highlights in terms of being a modeler that were either easy or challenging to set up this concept?
Yeah, thanks, Pete. Hi, everyone.
Really?
To answer your question, Pete, I think this was a pretty exciting project because it's fairly novel. So connecting these types of models was something that we hadn't done before, and we found some really interesting results in doing that, actually, and sort of an interesting, like, lots more questions obviously came out of it. I think that was the main part that was really interesting. So, for example, we had a look at certain orientations of these flow paths with increased lateral flow, so the paleochannels. And when we kind of did this modeling and sort of thought about it a bit more in detail, we thought, well, what would happen if the paleochannel was the orientation was different? And when we ran that, the results actually changed quite a bit in terms of the flow patterns. So it was really interesting to see how detailed you can get with this modeling approach, and that when we are able to actually calibrate and parameterize the whole model, I think we will be in a good position to actually see if we lose more nutrients than we thought from paddocks.
Yeah. But at this early stage, are you confident, Felix, that the model is giving you a reasonable picture of what's happening with the flows?
I'm relatively confident that we have a model that in its structure does something that we can rely on. Okay. So that's the model structure. However, I'm not super confident yet in actual numbers.
Sure.
For that, we will need parameterization. And when we have parameterizations for the specific soils and the specific conditions, we might then actually find that it might have no impact on the nutrient loss as well. It's possible.
All the what ifs. Okay.
Yeah.
Oh, that's it.
Can I ask if there was a groundwater specialist on the gig at all?
Project.
Do you have a hydrogeologist on the project?
No, there wasn't. No, we didn't have a hydrogeologist on the project. And we relied heavily on the field knowledge that Marcus and Dave Morrison had based on their extensive time experience working in that area. So okay.
Yeah. And I had a question about the EMI mapping. Do you know how deep it's able to, how much depth it's able to penetrate?
Marcus, do you have any idea? My understanding is up to maybe about 2 meters, thereabouts.
About 3 meters, so it could be set for different zones to get the readings that you require. But around 3 is the deepest it'll go.
Okay.
Right, thanks.
Yeah, it's interesting. I come from a hydrogeological background, and so Hanshi and I spoke about this really early on in the piece. And one of the very first jobs that I did was actually going out and doing bore work, drilling bores up in the around the Sunshine Coast, all of the forestry that's up there before any of that new development was put in place. And it was looking just at this same kind of topic, how the paleochannels were going to not just, it wasn't just about nutrients and pollutant transport, but affect potentially the development and all of that. And I'm fascinated by it sounds like you haven't yet achieved or got particular results to kind of turn to and look at yet, but I'd be really keen to see what you come up with. Because this is, as you say, Felix, I haven't seen this type of integration of models in this level, this way. And I feel like groundwater is often just forgotten because it's hard to compute, it's hard to recognize.
Yeah.
But I suppose one of the things you said early on, Hunchy, was this ability. How can you take, and maybe Felix, you take a small, at a detailed scale, then to put it into a catchment model as well. So
so far we're only modeling at the paddock scale. We haven't even looked at connecting the paddocks together and routing the flow. So we're really only at the tip of the iceberg.
Yeah.
And the other the other thing that I was also thinking about is that with the EMI mapping, we're only looking at the very top end, the upper end of the paleochannel. We have no idea what the paleochannel system is like. Could there be multiple levels of paleochannels?
Inevitably.
They connect with each other. So
the way that they move through the landscape, the way that rivers, I'm actually the image you showed before of the map that showed where the paleochannels were in that landscape. I'm surprised you didn't see more in that southern part where around the meandering creek there, because I would expect to see the way that meandering creeks move, this kind of lateral shifting as well through the landscape, which changes with depth as well over time. Very cool.
But okay, I suppose as a project, it was, I think what you're trying, with all these projects, it's about trying to do what you can do best with, when it's a phased approach in working. So it's like I say, obviously for Marcus and for David, this is a nice opportunity. So Marcus, for you in this project, I'll come to you in a sec, Brian. So Marcus, for you in this project, is this helping you get maybe a better understanding of what you've been observing and what you might need to do in terms of responding at a paddock practice?
Yes, absolutely. So I've been investigating them now for 5 years, and we've had 20-ton excavators digging to the bottom of them. We've put a lot of time and effort into trying to understand them, and I think what it has shown me is that there isn't one description of a paleochannel, and that's part of our challenge, is that if we start looking at the catchment modelling side of it, we need to understand what particular paleochannel regime have we got, and to me there's even evidence that suggests that we've got different times. We've got almost contemporary channels, and then we've got ones that are much older, which were built on other sea level drainage systems, and so there's a lot to it, and I think that's the exciting part about it, that the more we look into it, and this project helped us all look into it further, is that it's complex, but it's absolutely there, and it's really influencing the way nutrients are moving across the landscape. The thing that drew my attention to it, and I just got up on my screen here at the moment, 5 years ago, a particular farm that I was assessing with my drone imagery, and this most unusual dendritic pattern of poor crop growth across the farm. And that's what sort of began that process of, well, there's some other sort of physical reason that the crop's doing poorly, and that led to the discovery of these sand features, and then the ramifications sort of have come out from there. But so I think we're all I've got multiple things on the go with it at the moment, and we're learning, really all the time more and more about them, and where they may be also different across the landscape.
So Marcus, in terms of sort of management sort of regimes or things that can happen at the paddock, like knowing that they are having an influence, but maybe not knowing, exact details, are there some initial approaches that have implications? Like, does it help explain why some paddocks perform maybe are less productive than others? Is it that sort of knowledge, or are there actually things?
Yes, and it's quite profound actually. It's this same sort of 5-year period has shifted it from farm-based management to block, so paddock or block as we call it in sugarcane. But now we're looking at sort of intra-paddock variability as being significant. And the particular one that I focus in on, the paleochannel, or these very poor performing, doesn't have to be paleochannels, can be other very poor performing parts of the paddock, is that they preferentially lose their nutrients because they're not utilized by the crop. So if the crop doesn't do well, whatever we've applied is just sitting there ready to be lost, to be leached out of the landscape. So the rest of the crop might be doing a reasonable job if we look at that way of taking up these things, but these nutrients, for example, but these poor zones are much higher contributors to poor water quality because we know it's not being used, but the crop is absolutely not taking it up. So I think that's one of the big shifts now, is that we're saying, what can we do? And with the paleochannel side of it, or the sand feature, I'm somewhat comfortable with sand feature and paleochannel, but because of the difference between some of the features in them. But we've actually gone in and done mitigation action. So we've actually dug them out, changed the soil properties, and we've got back to having normal crop growth, so we can physically change the characteristics of these zones. We've even done ones where we've preferentially applied nutrients to those zones only, and so we are experimenting. We know that we can increase the crop growth, but can we protect the water quality side of it? That's
sure. Yeah, sounds work in progress. Brian, did you have something you wanted to add to this conversation?
Yeah, so I suppose it's down a similar sort of line around management prescription. And I'm wondering if you're a farmer and you find that you've got a paleochannel running through your property, what are the implications and the management prescriptions that you might formulate, and are those going to be in tension with or aligned with, I guess, broader landscape management prescriptions, which might be to do, for example, with managing nutrient flow off of a catchment and into some kind of receiving environment? Yeah, I'm just wondering about both the on-ground practical implications and then the regional and any tension or alignment between the two.
Yeah, it sort of builds a bit on what you just explained, Marcus, I think, a little bit in terms of what you can and can't do with different parts of your paddock. But is there some more that you'd like to respond to, Brian, Marcus?
Yes, I think it's this finer scale management that we've just not. Well, to me, the farming community has had this view of I always picture it like a tarp thrown over the landscape. So I have a hydrology background, and that's the way we view the world, and it all sort of flows across and ends up in a drain, and eventually ends up in a river, and eventually ends up at the reef there somewhere. A very interesting paper that just came out a few weeks ago shows, I don't know whether any of you have actually seen the paper. It's submarine groundwater discharge exceeds river input as a source of nutrients to the Great Barrier Reef, and it's environmental science and technology, and it suggests through submarine groundwater discharge that perhaps 60% of nitrogen applied to the coastal landscape is actually making its way out to the sea, and we're never intercepting it from a monitoring point of view. So a big number, and a quite a controversial one. I would suggest it was in the on the radio and all sorts of things up here. But with my experience over the last 10 years, that's not an unrealistic figure, that we're not meeting when we're looking at monitoring this form of discharge. We're trying to collect it in drains and in rivers, and it's moving through the landscape and presenting itself potentially further down the catchment, and in some cases actually in the seabed before we even get to interact with it. So I think it's a really big part of the dynamics of the hydrology part of water quality that we don't really have a very good handle on.
Oh, interesting.
I suppose just on a, again, maybe the practical sort of bent, if you were to try to, I guess, interrupt or remove a paleochannel as a feature on your property, that sounds like a lot of earthworks. Would it even be sort of feasible to countenance doing that, or is it something that you would slice, like you would seek to try to homogenize or reprofile the soil in slices across your property?
Yes, I think you're right in the slices. So they're the trials that we've done. We've gone from removing 2,000 cubic meters of one of them to, just to understand the sheer scale and the depth. Yeah, we couldn't dig to the bottom of it. It just caved in. So it was some of them are enormous, but the system we have at the moment is on a controlled traffic situation. Is when you know where the crop zone is, you just change the soil properties within that growing bed, if you like, almost the pot that's underneath the crop, because there's no way you can change the feature itself. They're just not all. Remember, I'm always happy to say they're all different, but most of the ones that I've interacted with are just too significant. So within the root zone of the plant, that's where you want to add. In our case, we've added clay in particular. So it's a physical characteristics of these sandy soils that all nutrients and moisture is lost. So we're just sort of manipulating that very small zone into a way that things can be captured and held, and that the plant can interact with them. So to me, it's a management practice around identifying that zone, which is often quite small area of a paddock, and then doing some mitigation action so that it's a long-living or long-lasting mitigation action to retain those nutrients.
Can I just add to this? It sounds a little like the intention for the management action is focused only on the outcomes for the farmer or whoever's managing the land, and so it's the impact is on crop value, and I wonder whether or not putting, just your comment before about throwing a tarp over the area, further to this, that I suppose there might need to be some consideration about how those types of management actions could cause further impact downstream or upstream, even by not allowing the earth to drain as it has been put in place. And just a thought there about,
so on the ones that we've studied quite well, they actually most of the time go underneath the drain anyway. So people have cut drains in the landscape, sometimes meters deep, but the paleochannel is even deeper than that. So they've not got to the point that they've, say, controlled that whole flow into the channel or into their drainage line. So I think it's very difficult for even the action where we removed the 2,000 cubic meters. We didn't really interrupt the flow of that channel because it was still meters below our earthworks and still flowing quite freely. So smaller ones, I think you could potentially interrupt them, and that would be an absolute concern on particularly some of these lower elevation cane farms. But most of the time, the features are quite significant, and we're fiddling around with the sort of bit on the top, maybe the first not even a meter that we're trying to get the crop to grow in. And from a crop perspective, the sort of double value that we get from it is that the grower wants to grow more cane on that particular part of the farm. They're very poor yielding, these particular features. So the benefit that occurs is that by him understanding and changing those properties, he grows better cane, but he's probably applying the same fertilizer regardless of whether he changed the properties of the soil within the paleochannel or not. So that direct crop above it has the chance to hold on to it, the applied nutrients. As far as moving the other nutrients from a wider area, that's definitely a different thing. But as far as trapping the nutrients that are applied directly above the feature, by growing more crop, he's definitely soaking up more of what's being applied.
But it is a fascinating comment about whether there's leakage, and because I suppose there's something that the whole Tully catchment is sort of quite a disproportionately high loss catchment compared to some of the others. So there's sort of a few sort of macro scale issues sort of pointing out, some other things. So She is, or look to the rest of the audience. Are there any other questions? We're having a nice sort of two-way conversation. If anyone else listening in wanted to sort of clarify with She or Marcus? Okay.
Hi there.
Please,
My name is
Mahmood.
Mahmood from James Cook University. Yeah, really interesting talk, She. And I agree with you, Sarah, that I think groundwater flow can be a big contributor to nutrients and other contaminants, but it's largely overlooked when we're talking about catchment management. Yeah, I would be really interested to see some of the results from this study to actually see what is the contribution of those paleochannels to nutrient transport. And we've been using radioisotopes and environmental tracers to actually detect groundwater flow and groundwater movement in some of the work that we've been doing to actually quantify the groundwater discharge that goes into rivers. And quantify the amount of nutrients being transported by groundwater. So it would be interesting if we, if the results from this model could also be validated, maybe with some field data. Is there field data available to actually validate the model, to see actually if that conceptual model that you showed at the beginning is being truly presented by the model?
Okay, so we've only got the conceptual framework for modeling. We don't have the field data to calibrate to validate the model. So far we've only been modeling flow. We haven't even gone to modeling nutrients or other contaminants yet. So it'll be really useful if if some of your sites have paleochannels to test the model and then use your data as information to check the model, see if it's performing all right or not. Yeah. So right now it's at the very conceptual level, and the experiments that we're doing is just virtually. So the numbers that we show you are just, relative to a scenario, paleochannel or no paleochannel, how much has flow increased. So we're only at that stage.
Yeah. It's very much a phased bit of work, but Mahmood, but it might be interesting whether any of your data connect in sort of so the radio tracing, that's quite a specific technique, and you've obviously got some confidence that's giving you some indication of where things are going. Yeah, so it would be good to see if we could use those techniques to see where the water into drains is actually coming from. Is it mostly surface water that's going into those drains, or is it groundwater? What portion is groundwater? What portion is surface water? So definitely, we could maybe catch up and see what we can do in that space.
Yeah, definitely. Thanks, Mahmood. Thank you.
Jenny, what are you going to contribute here? What's happening?
I was just going to say, is my camera working yet?
Yes, it is. Hello, Jenny.
Now it is. It's working. I was going to say, this is one of the reasons why this is a Big Ideas Zoom seminar. It's talking about, okay, we've done a pilot study. Now we've got a foundation, a conceptual diagram or conceptual framework where we can start plugging other bits of data in. And so I can see a lot of work happening in this space in the future, and it's thanks to She, Alluvium and Jarrigan for pulling this one all together. And I'm looking forward to posting the final report of the project online soon. We've had some very good peer review reports back on it, and I think that's going to just continue to move this project along. So congratulations to everyone involved. It's been a pleasure seeing it unfold.
Thanks, Jenny. Thanks for your support.
Well, that's great to hear, Jenny. And we'll try and keep everyone up to date when that report comes through. Joel, did you have something you wanted to say?
Just bear with me. Yes. Pierre. I guess one of the things I was wondering is along those same lines, I think, like I've been working on some projects in the department, and one of the key reference documents for me is the Queensland Water Model Network Best Guidelines, Best Practice Guidelines. And I guess one of the things I was wondering is what's the opportunity to integrate some of these learnings and practices within future revisions of these. And I guess for this project, was that guidance a tool that was used, and is that something that we can utilize, discuss those links with that best practice guidance document? Is that an opportunity to address some of those issues through the Big Ideas process?
Good question, Joel. Good question. I don't know. Hanshi, have you ever looked at them to see what they might offer? Maybe not. Jenny might be more familiar with them.
No, unfortunately not. Maybe Jenny, help.
Look, I don't think they've been explicitly considered in this project, but the principles would be implicit in a lot of the work that Hanshi's done, because in working with modelers that do this stuff. But I think it's a very good idea to revisit those principles, because they were actually done in the first year of network, and say, okay, if we're going to do big ideas, we need to come back to the fundamentals and the foundational stuff, which is, okay, best practice, how do we do it? Are we doing it the right way? How can we apply it? It's using the stuff like the critical review of climate change and modelling. So we've done this foundational stuff in the past, but we need to actually integrate it. And I say we, as a Secretariat, needs to think very carefully as to how we can make sure that that is carried on and woven into projects as they come through. So
like
it's a very timely question. Thanks, Joel.
It's nice I can give you something to revise, and but it's good to know some people like Joel are looking at it. Like, be careful, Joel. I think you might be opening yourself up to some testing of which is true. Like each of the projects are giving us a different perspective or building on what was known before. So it is a bit of an iterative process. But yeah, good observation. Thanks, Joel.
No worries, Pierre. Yeah, and for me, it's just sort of like these are great case studies, and like any best practice framework, that's going to continue to evolve. So it's about understanding is that best practice framework up to scratch, or is it the project's up to scratch? What is the alignment? So that's just what as I've been listening to this presentation, that's one of the things that's just been kicking around in the back of my mind.
No, that's a good point. The whole sort of application of the guidelines, and these could be used as case studies. For example, they go, okay, here's the application, pull out the key threads from the guidelines. This is specifically highlighted in paleochannels, these key points. So I'm going to take a couple of notes on that, but luckily this is recorded, and that's something I'll have to try and follow up sooner rather than later, because we've got more projects on stream, and if you don't actually address them before you get overwhelmed, it just gets harder. But yeah, but no, thanks, Phil. That was really good.
Now, Hanshi, you've sort of flagged a little bit that you want to do some more experiments. You need to get some more other data coming in to help maybe sort of calibrate/validate, parameterize. We've got a range of different things happening. So do you see some opportunities coming up? Like you've got people like Marcus and Dave who are busy there in the field. So what are your thoughts on what will be happening next?
Well, when I get back to Australia, I'll try and catch up with Marcus to check out more about his field monitoring activities, and with Mahmood as well. We need to have a chat. We've actually had a chat with Tony Weber. And he's keen to continue working on the virtual experiments, and perhaps to get to have a chat with the 2Flow group to see if there is any opportunities to use the modeling framework in the virtual experiments. Yeah, currently we think we'll use Morphflow, but because 2Flow is so widely used in Australia, he was thinking that maybe, you know, we can have a chat with them and see if there's an opportunity to work together with them. Yeah, to include them in that framework and to see if 2Flow can be coupled with AppSim, which apparently is interesting because it's not something that a lot of people have really tried to do.
Yeah.
So that's the future work, yeah.
No, that's good. Well, you've got all the agricultural players here, so if it's got scope, then here's a place that could potentially work. So that'd be great.
Yeah.
Folks, just conscious of time and people slowly slipping away, which is fine. And but for those that are staying on, yeah, Mahmood, before we disappear, another question?
Yeah, sorry. Yeah, it was just one more question. So building these strong models would require good data. You know, the models are as good as the data that we as input data. I'm just wondering, you know, data like if you're using Modflow, for example, like hydraulic heads or hydraulic conductivity with specific yield.
Yeah.
How are we looking in terms of data? Is this sort of data available, or is this something that you know we need to focus on? You know, monitoring bores, pumping tests for determining hydraulic conductivities.
Yeah, those are things we need to do. Maybe we need to identify because the soil can be quite variable. We do have some information that can help in identifying hydraulic conductivity, but because it's so variable, I guess what we need to do is if we were to actually engage in more field monitoring activities, apart from what Marcus is doing and what you yourself are doing, we need to identify the sites that maybe the sites that have the most paleochannels and focus more detailed monitoring on those areas. And interestingly also, as what Sarah and everybody else has been commenting is that, and yourself, is that we're only looking at the top of the paleochannels and what's actually below. Do we need to do more, use different techniques to try mapping these paleochannels at greater depths than what has been mapped using EMI? So there's scope for a lot of work. So I guess we do it step by step. Yeah.
We need some people that think in 3 dimensions. Thinking the X, the Y, and the Z properties of these things. Yeah. I'm surprised at how little of, because the work that I did in this space was 20 years ago, and it feels like nothing has changed, and that it hasn't actually, it feels like not much is really developed in terms of how we do integrate all of this information together. So, I mean, thank you for bringing it to the forefront of the conversation, but also, wow, why aren't we seeing more and more of this sort of thing kind of playing out? Because it really is such a, my geology brain just wants to see more of this. Yeah. Groundwater, Jenny.
Marcus, you had your hand up there before. Was there something else you wanted to add?
Yes, I just wanted to point out that I've got some projects underway at the moment, which will add, I think, some numbers to it. So I've got a 50 paired site project where I'm actually doing the soil testing for 50 sites. So that's within the paleochannel and the adjacent cropping soil next to it. And then I'm also setting up a couple of sites at the moment in the paleochannel to monitor the groundwater flow through it. So I'm not going to end up with flow volume, but I will certainly end up with concentrations. I'll end up with the water table height in the channel as well as the surrounding farmland soils. So we'll start to end up with some other numbers or some other properties of around the way that they react in the landscape. By the end of this wet season, we'll have some more information.
Oh, that sounds
and
good.
also just on the Mahmood side of it, and I'll be using also, hopefully I'll get some radon values. So we'll be doing some radiogenic tracer work on some of the water that is in them and the drains beside them as well.
Yeah.
Excellent.
So that sounds good, Marcus. So Marcus, for you, this has obviously been a bit of a bonus of a project to be involved in. So the concept of the model is helping you in how you can look at things, you think?
Yes. So I sort of bring a bit of a background. So my honours was in looking at a preferential pathway flow through agricultural soils. So I've sort of, it's been a very nice opportunity to expand in an area that I've got a reasonable feel for. And I agree with Sarah before that for the last decade or so, we've just ignored this this flip side of the world, this underneath the surface side, which is just such a big contributor and so dynamic and so interesting. So it's a really nice focus now to bring it out and for everyone to start doing some extra work on how waters are moving through this part of the landscape.
Fantastic. That's good. Well, there you go. There's definitely some good highlights, and in terms of the concept of big ideas, it might be a formative one here. Like Hanshi, it sounds like just creating the simple model is a really critical first step. It's just discussion I'm hearing today. There's a lot of people building off that.
Well, I think the big ideas need a great team for it to be successful. Yeah, we got Ralph as well, who is a key component of our project. So yeah, we couldn't have done it without this team.
Yeah. So Ralph, what was your involvement in the project?
I did most of the spatial modeling, some GIS analysis, basically overlay all the different data sets that we had, try to combine them all and characterize each of the units of analysis, which are our paddocks.
Okay.
And yeah, that's it.
You provide that important technical need of shifting around. Well, like it, and it is, and it's sort of based on what even Marcus is saying. There's a whole range of different information sets that can be involved. So how you can build and I suppose over time figure out which ones are the critical ones, or maybe some are de facto indicators of other things. So I think you've created a bit of a learning lab, Hanshi.
Oh. No. Yeah, well, thanks. Yeah, Ralph was crucial, and he was really helpful to help guide us in looking at spatial relationships because of his GIS background. So I think that's really important as well. Yeah, because you need to think at different scales, right? And the relationships between different elements of the landscape and how we model them. So that his inputs were crucial, very, very important for the project as well.
That's good. Thanks, Ralph. That was good. I appreciate your input there at the end. Folks, I think we've most likely come to a little bit of a conclusion, unless are there any last sort of questions before people drop away? So Jenny, I think you get some, I'm glad we've picked on this project to focus as a case study. I think it's definitely got some interest, and it's been a nice application.
It's been an exciting project the whole way through.
Yeah.
It's the pilot ones, you sort of think, oh, well, let's put some, don't have to put a lot of money down, but you get some interesting stuff happen. And no, as is often the case, it's a cracker. So looking forward to what happens next. We've got a good foundation to go from here. I agree that groundwater is underrepresented in what we do. And I hope that this might actually help to create a bit more of an interest in getting more involved in it, getting some data and doing some good stuff. But yeah, I look forward to seeing what happens next.
Okay.
Oh, Joel's put his hand up.
Yeah, Joel.
Well, sorry, I'm on the phone today. I was actually just wondering, Pete, what the plan is for the next one. I think the next one's a face-to-face engagement.
Yeah, we had thrown that as one, but we've had to sort of pull back from that. So look, this is the end of the series. So yeah, no, we're not meeting face-to-face, unfortunately. I think there's been a lot of activity on. But look, I appreciate your interest, and I suppose we're sitting down the next few weeks to sort of plan how next year goes. And I think we're really keen to sort of look at some of these little showcases to see how we can draw them out. So might talk to you a bit more, Joel, as well, because I mean,
Yeah, for sure.
You've come along to a few of the different ones, so keen to sort of hear what sort of keeps your interest. So like we get different people from each of the different activities, but I know there's something very hands-on that we can get out of these activities, and we're keen to do that.
It sort of sounds sorry, Pete.
Sure.
No, it sort of sounds like what you pointed out before about this really being an exercise in learning for everybody, that maybe there's an ongoing element to that we can continue to support and help drive through QWMN, Jenny.
Open to ideas.
Get some hydrologists, geology minded. Get some of the surface water people with some groundwater training in there, I think is a big challenge.
Oh, can I add geomorphologists as well? I think really important.
No, I think we always try how we can to get the different mix in, and I suppose it's interesting what draws different people in. This project certainly is very transdisciplinary, so it needs it. So, yeah. Okay, folks.
Say one last thing before we go.
Yes, please.
This project has created a foundation, so you've got a conceptual framework. What has to happen next is there needs to be, that momentum needs to be sustained. One of the ways to do that, of course, is if there is, looking around for resources, funding opportunities. That's one of the things that the network luckily has been able to do so far, and I'm hoping that next year we'll be able to go out to tender, have another open tender, which may fit, may not fit this topic, but it's just something that I think is really important. You need that ongoing investment to be able to build something that actually has an impact, rather than just is a couple of project reports, however important they are.
Well, we can see Marcus is already continuing the flow, so I think in the Jarragon group, I'm sure they're going to keep asking questions because they're trying to figure out what it means for managing those floodplains there. So for a range of other assets as well, not just the agricultural perspectives. Folks, thanks very much. Hunshi, fantastic. Thanks. That was a nice simple presentation. We'll share that with everyone when we're finished, and there'll be a recording we'll send out for those who didn't join us. But no, we've had a good 25, 30 people join us today, so that was great. So thanks everyone, and watch out, Sarah. You might become the geomorphologist, champion. So I think there's going to be a few.
Yeah. I'm not really asking for that.
Well, be careful. You the hand is up. No, but thanks, Jenny. Good to see you on board too, Jenny. And thanks, Marcus, very much for your input and interpretation of what it is. Nice to meet you, Mahmoud, and great, Joel, for your input. So cheers, everyone. We'll see you soon. Bye.
Thank you. Bye. Thank you.